Hello, welcome to PCB tutorial. This tutorial helps to hardware design engineer as well as high speed PCB designer. If the high speed PCB designer face the problem while routing the LPDDR to FPGA, they can refer this tutorial. When your design consists of LPDDR, low power DDR, SDRAM, and FPGA, you have to keep the LPDDR RAM nearer to the FPGA. That is the basic thumb rule used while designing the PCB. Hello, this diagram shows the FPGA and two LPDDRs are placed here and U7 is here. These two are LPDDRs and here FPGA has been kept. The routing pattern and length matching are as shown in the figure and balanced T topology has been followed. This tutorial helps to the beginner who is going to design the high-speed design. A balanced T topology looks like this. A microstrip track from the FPGA and then a track is routed as a strip line and again the track came to the outer layer microstrip and it is connecting to the LPDDR. And balanced T topology is strictly followed while routing the LPDDR to FPGA. A PCB designer has to refer the data sheet while designing the PCB. It will take lengthy of time. It will be the wastage of time. Goes on, read the data sheet. He has to search the guidelines inside the data sheet. But this tutorial gives a quick reference to the high-speed PCB designer. These are all the rules while routing the high-speed tracks. First thing, the high-speed designer has to keep it in mind. The maximum length of the clock must be 150 picosecond. The length approximately 500 mils. In FR4 materials, 900 mils is acceptable because in FR4 material, the speed of the signal is more. The skew between N and P of the differential clock Ck and Ck bar must be plus or minus 2 picosecond. 12 mils maximum is the skew between positive signal as well as negative signal of the clock. The third thumb rule is the skew between the differential strobe signals DQS and DQS bar will be plus or minus 5 picosecond. 20 mils maximum is acceptable. The fourth rule is the skew between data and data mask with the DQS and DQS bar will be 10 picosecond. 60 mils maximum is tolerance is acceptable between DQS and DQS bar. The skew between clock and data signals must be within 50 picoseconds, 300 mils. Is the skew or the tolerance between the data signal and the clock signal. The clock signal must be 300 mils more than the data signal length is acceptable in this design. More than that, it is not acceptable. It should be within 300 mils. Sixth rule, the skew between command address and clock is 20 picoseconds. It is 20 mils. Compared to the clock signal, the command address signals must be within the 20 mils tolerance. Length matching in LPDDR, you have to analyze the signal by using signal integrity software as given by you. The software which you are going to use that can do the analysis of the signal, these differential signals. The more eye opening is required. The more eye opening represents the signals are transmitted properly to the destination. If the eye opening is very narrow, then it represents the signal is not reaching to the destination with the proper manner. For that, sufficient determinations are provided to control the signals to travel to the destination with greater eye opening. The single-ended signal, high-speed signal in this design can be analyzed by using the signal integrity single-ended track analysis. In this, the clock signals or the high-speed signal which is traveling from source to destination will appear like this. A reflection will appear like this. By providing series termination, it can be solved. Thank you for watching.